So particular isotope has a half-life of, so that's the half-life of 67 days. So we're given the half-life, so it's basically radioactive decay. If you start with 1 kilogram, that's your initial amount of the isotope, how much will remain in 130 days, in 260 days? Very similar problem. We've done this type before. Let's write down the formulas. The new value is equal to the initial value times its decay, so it's half to the time that has gone by divided by the half-life of that isotope. So we want to know the final amount that is left. We start with 1 kilogram, that's the initial amount. We have a T half of 67 days, and T is equal to how many days have gone by. Let's do the first one first, so that's 130 days. Just make sure the units of time match. If not, you'll have to change one or the other. Times half to the T, that's the number of days that have gone by, so that is 130, over 67 days is the half-life. So I'm going to use my calculator. So that rounded to the thousandths place is 0.261 kilograms. So if you start off with 1 kilogram, at time t equals 0, 1 kilogram. At time t equals 130 days, this has a very fast half-life. It's just declining really fast. In 130 days, you have only 0.261 kilograms. And as you can imagine, it'll be even less. In 260 days, it's declining super fast. Very little will be left in 260 days. So let's just quickly calculate how much is left. So we have N equals, so this is going to be the same thing, except we're going to change the time to 260 days. So 260 divided by 67, which is the half-life. The only thing we're changing is the T. Everything else remains the same. I'm going to use my calculator, and what I get is 0.068. That's the answer, and of course I'm sure this will be in the question, so you don't have to write down kilograms. So just see how quickly this quantity decreases. Super fast, very little left in 260 days.